Welcome to EDU World Space.
Okay, so this is the free body diagram for this question. So we know the net force along the y direction should be equal to 0 since we consider it's at the equilibrium. So we have NA plus NB cosine 30 degree plus T sine 30 degree minus W minus FB sine 30 degree is equal to 0. NA here is the normal force at point A, NB here is the normal force at point B, and T here is the tension. In other words, the force in the cable needed to begin in the lift, which is the force we're looking for to determine. And W here is the weight of the garbage bin, and FB here is the friction at point B. So we know the friction at point B can be equal to mu B times NB. So if we use mu B NB substitute for FB, we have such equation here, which is T sine 30 degree is equal to W plus mu B NB sine 30 degree minus NA minus NB cosine 30 degree. So we have NB is equal to T sine 30 degree plus NA minus W over mu B times sine 30 degree minus cosine 30 degree. And we know Fx, which is the net force along the x direction, is also equal to 0. So we have T cosine 30 degree minus FB cosine 30 degree minus NB sine 30 degree minus FA is equal to 0. We know FA can be equal to mu A NA. So we have T cosine 30 degree is equal to mu B NB cosine 30 degree plus NB sine 30 degree. And then plus mu A NA. And this will give us NB is equal to T cosine 30 degree minus mu A NA over mu B cosine 30 degree plus sine 30 degree. So now we can set out these two equations equal to each other since both of them are equal to NB. So we know sine 30 degree is 1/2 and cosine 30 degree is equal to square root 3 over 2. So now we have the such equation for the tension T. So now let's take a look at the moments about B. So we consider the counterclockwise moment is positive and the clockwise moment is negative. So we have such equation for the moments at B. So eventually we have the NA, which is the normal force at point A, is equal to the weight of the garage bin times 12 feet over 22 feet. And then we can substitute the weights for the garage bin. So we have 8,500 pounds times 12 feet over 22 feet. And this will give us the normal force at point A is equal to 4636.36 pounds. So now we can substitute the variables with the values here, since we know the weight of the garbage bin is 8,500 pounds, and the coefficient of the static friction at point B is 0.2, and the normal force at point A is 4636.36 pounds, and the coefficient of the static friction at point A is 0.3. So now we have T is equal to 8,500 pounds over 2 times square root 3 times 0.2 plus 1 minus 4636.36 pounds over 2 times square root 3 times 0.2 plus 0.3 times 0.2 and then minus square root 3 times 0.3. And this will give us the tension, which is the force in the cable needed to begin the lift, is equal to 3,666.49 pounds. And this is the answer for this question.